So first we'll understand that concept of work done. ठीक है, सपोज एक स्प्रिंग है तो स्प्रिंग कांस्टेंट k है. Now to stretch this spring by an amount of x, how much work is need to be done? What I'm saying, suppose you have a spring and to stretch this spring by an amount of x, how much works need to be done for that?
Of x square.
Exactly. So how will do? So work done W will be nothing but minus f dx. Okay. Let us assume that initial length is 0. Now you are stretching by an amount of x. And you know for spring f equals to minus kx. Now if you substitute it here, you will get kx dx. And that limit is 0 to x. So obviously that work done to stretch that spring by an amount of x will be, if you do that integration, it's a very simple integration, you will get kx square by 2. And that is nothing but potential energy, right? What you have seen. Okay. Now I'll solve problem. So suppose you have a spring number 1. Spring number 1. Its spring constant is given, that is k. Now to stretch the spring by an amount of x, the work need to be done, that is given as W. So there is another spring number 2. The spring constant is unknown, that you have to calculate actually. K dash. To stretch the spring by an amount of x by 2, the work done is twice W. मतलब सेकेंड स्प्रिंग को x by 2 अमाउंट ऑफ स्ट्रेच करने के लिए कितना वर्क डन करना पड़ रहा है? ट्वाइस दैट ऑफ फर्स्ट स्प्रिंग. फर्स्ट स्प्रिंग को कितना स्ट्रेच किया? x स्ट्रेच करने के लिए आपको वर्क डन कितना करना पड़ रहा है? W करना पड़ रहा है. सेकेंड स्प्रिंग को x by 2 स्ट्रेच करने के लिए ट्वाइस W वर्क करना पड़ रहा है. And it is double, right? So what will be the spring constant of second spring? It's a very simple question, right?
Yes, sir.
But this kind of question used to ask in exam. That's why I'm doing. So for first spring, if you write that equation, work done equation, it will be how much? K by 2 x square, right? This will be that first work done. Let us to stretch that first spring by an amount of x. Okay. Now for second spring, that work will be W2, and that will be simply K dash, its spring constant that we are going to calculate, divide by 2, and that amount of stretching that is given as x by 2 whole square. So according to that given condition, W2 is twice of W1, right? Now if you substitute W2, that is K dash by 2 x by 2 whole square equals to twice W1, that is K by 2 x square. Okay. So this 2 will be cancelled, x square will be cancelled. So we'll get K dash equals to how much? So this is 1 by 2 square, that is 4 into 2, that is 8, and you have K. So it will be 8K. Okay. Is it clear?
Yes, sir.
Everybody clear this part?
Yes, sir.
So this kind of is, the concept is very simple, but this kind of question used to ask, especially in JEST. Okay, so that's why you have to remember, right, these things. Shall I erase?
Yes, sir.
So now another concept about that spring constant. Suppose you have one spring. Okay, its length is first spring constant is K and its length is L. Okay, now you divided this spring, or you divided that spring by two equal parts. So now you have two springs. Okay, their length is L by 2, L by 2. So what I am trying to say you, आपका एक स्प्रिंग गिवन है, इसका स्प्रिंग कांस्टेंट K है, लेंथ L है. आपने इस स्प्रिंग को दो पार्ट में डिवाइड कर दिया, each will have equal length. Okay, what will be the spring constant of these two parts? इसका कितना होगा spring constant?
K.
Why? So initially you have string that length is L, spring constant is K. You have to divide it into two equal parts, each having length L by 2. Now what will be that spring constant of each parts? So you know that spring constant, this concept is really important for competitive exams. Spring constant is inversely proportional to length for a given material. Okay, अगर आपका मटेरियल फिक्स्ड है, सपोज ये कोई इसका एलिमेंट का बना हुआ है, उसका लेंथ के ऊपर डिपेंड करेगा, तो इसके लिए कितना है, लेंथ L है, राइट? So how much it will be? So K dash, let us assume for these parts it is K dash, so it will be how much? 1 by L by 2, and 2 will come to upper side, so it will becomes 2 by L. So you can write from this equation, if you take this is your equation number 1 and this is your 2, then K dash by K, that will become simply 2. So you can write K dash equals to twice K. Okay. So for this it will be twice K, for this equals to twice K. Okay. Okay. Is this part clear?
Yes, sir.
Shall I erase?
Yes, sir.
I'll give homework.
Yes, sir.
Okay. Now suppose मान लो आपने इसको दो पार्ट में डिवाइड किया, but their length is not equal. This one is L by 3 and this this one is L by 4 and this is 3L by 4. Now you have to calculate. Please do that homework, right? Yesterday जो आप लोगों को होमवर्क दिया है, सब लोगों ने किए हो? सब लोगों ने किए हो जो होमवर्क गिवन है आपको? स्पेस हमारे जवाब स्पेस, हाँ, दो लोगों ने तो भेजा है, बाकी लोगों ने? Everybody done this homework?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
ग्रुप में शेयर कर देना, ठीक है, मैं चेक करूंगा. So now homework is you have string, you have divided but not in equal part. This length is L by 4, this is 3L by 4. So you have to calculate that spring constant for this. K dash for this is how much? For this it will be how much? Okay, please do it. Okay, कर लोगे ना?
Yes, sir.
Yes, sir.
Okay. Now you know for oscillation, time period was how much? 2 pi by omega, right? And omega was how much? omega was, the expression for omega was root over k by m, right? Right? So time period will become 2 pi root over m by k. M by k. This is the expression for time period of spring mass system. This is the expression for time period of spring mass system. The mass of this block is m and k is the spring constant. So this is the time period. Okay. Now suppose you have many springs. Then what will be the expression? So just in place of k, you have to substitute that k equivalent. So suppose you have spring mass system in which there are many number of springs. So how will calculate the time period of oscillation for that system? So there will be one mass, there will be no change in mass, but for that system you have to calculate equivalent spring constant. So for a system of mass or system of spring, the time period will become 2 pi square root of m divided by k equivalent. Just I'll give that example, it will be clear. So this is the expression when you will have many number of springs. Okay. Okay. Now समझ में आ रहा है क्लास में? Are you getting?
वो m by kl लिखा है ना?
Not k, k e. K
K E.
it means k equivalent.
Oh, okay.
Okay. Now I'll use these formulas, and this formula will be useful when we will deal with oscillation. Okay. Now whatever discussion we'll do, this formula will be useful. So suppose you have system of two springs. Okay. The spring constant of this spring is k1, and for this it is k2, and you have a block having mass m. Okay. And this side, the k1 spring is attached with some wall. Okay. Now you have displaced this mass by a small amount, because for any oscillation, first you have to give some displacement of block, right? So initially you have to apply some force. Whenever we are looking for oscillation, initially you have to give some displacement. For that you have to supply some force, okay, to check that oscillation. So you have displaced this block by an amount of x, and you know the spring is assumed to be massless, right? So when you will apply this, when you will stress this spring by an amount of x, or what I'm saying, if you displace this mass by an amount of x, there will be restoring force, right? Is not it?
Yes, sir.
So this restoring force F, so it will be equal everywhere, because you have assumed that spring is massless. So when, if you remember that pulley system, so tension is same everywhere. Why? Because in pulley system you used to assume that the string is massless, right? So same concept will be applied here. So your that assumption is that spring is massless, so F is like a tension, so it will be uniform everywhere. So force will be uniform. So when you displace this block by an amount of x, so there will be opposite force, that is restoring force, that will be uniform everywhere. So whatever force is acting here in spring 1, it will be same as for spring 2 also. Now will that stretching of this spring and this spring will be same? क्या इनका और इनका स्ट्रेचिंग सेम होगा? नहीं होगा, क्योंकि फोर्स देखो, फोर्स सब दोनों का सेम है. The force that is same, but spring constant is different, right? So F equals to kx, F is same, k is different, so obviously the displacement will be different. So for this, let us assume that displacement is x on or stretching is x on, and for this, let us assume that stretching is x2. So how is this part clear what I'm saying? So you have a two springs, they are connected in series. They are connected in series. So if you displace this block by an amount of x, so the opposite or restoring force will be uniform everywhere. But two springs have different spring constant, so their stretching will be different. Now, what will be the equivalent spring constant of this combined system? So to understand this, I'll draw a single spring. And let us assume this spring constant of this spring is K equivalent. Now, if you displace this mass by an amount of x, so force will be same as this case. So here that K equivalent is actually the equivalent spring constant of these two systems. Okay. So again, you are applying this or displace this system by an amount of x, so that force will be same. Here also will be same. Okay. Now this stretching, let us assume this stretching is x. तो इसमें जितना स्ट्रेच होगा x, ये किसके बराबर होगा? इनका स्ट्रेचिंग प्लस इनका स्ट्रेचिंग, क्योंकि ये जो स्प्रिंग है ये दोनों का इक्विवेलेंट है. So what I can write that x equals to x1 plus x2. And from here, what I can write in place of x, I can write f divided by ke, because this is x is the stretching of this string. So I can write in place of x, I can write f by ke, and in place of x1, what I can write f by k1. In place of x2, I can write f by k2. So k equivalent will become, because force will be cancelled, so k equivalent will become k1 k2 divided by k1 plus k2. Is this part clear?
Sir.
Yes, sir.
सबको क्लियर है ये वाला पार्ट?
Yes, sir.
किसी का कोई डाउट है तो पूछो. No doubt, right?
Yes, sir.
Okay. Now trick, how we'll understand that whether two springs, so what is the conclusion? If two springs are connected in series, their equivalent will be just like a opposite of resistance, right? For resistance, if they are connected in series, then it will be R1 and R1 plus R2, right? If they are connected in parallel, R1 R2 divided by R1 plus R2. But for spring system, it is exactly opposite. If it is they are connected in series, then it will be K1 K2 divided by K1 plus K2. If they are connected in parallel, it will be K1 plus K2. But how will understand whether they are connecting in series or in parallel? कैसे आप समझोगे? तो जब सिस्टम ये तो बहुत सिंपल है, जब सिस्टम कॉम्प्लिकेटेड आएगा तब अंडरस्टैंड के लिए क्या करना है आपको? कोई अगर सिस्टम कोई स्प्रिंग अगर सीरीज में कनेक्ट है तो कैसे आप समझोगे उसको? एक स्प्रिंग सपोज मान लो ये इसको ले लो आप, दिस स्प्रिंग आई एम अज्यूमिंग. सो इफ इट इज कनेक्टेड इन सीरीज, then one of its end will be connected in either in wall or in block. मतलब कोई एक स्प्रिंग जो है सीरीज में अगर कनेक्ट है तो फिर क्या होगा? एक एंड आइदर वॉल में कनेक्ट हो और ब्लॉक में कनेक्ट है, और दूसरा जो एंड होगा वो दूसरा कोई स्प्रिंग के एंड के साथ कनेक्ट रहेगा. If a spring is connected in series, how will understand? One of its end either will be connected with wall or with block, and other end will be connected to on end of the second spring. ठीक है ना? यही है, देखो एक स्प्रिंग इसका वॉल के साथ कनेक्ट है, दूसरा सेकंड स्प्रिंग का एक एंड के साथ कनेक्ट है. ठीक है. Why I am giving that example? Because when I'll come to the second discussion, it will be clear. Now suppose let us take this case. Let us take that spring constant of this spring is K1, and for this let us take K2, and this is your block, its mass is M, and this is your wall. क्या ये दोनों स्प्रिंग सीरीज में कनेक्ट है? हाँ?
No, sir.
Why? क्यों नहीं है? क्योंकि देखो सीरीज में है. सीरीज का कंडीशन क्या बोला था मैंने कि एक एंड आइदर ब्लॉक के साथ कनेक्ट होगा, ब्लॉक के साथ
So it
कनेक्ट.
is
हाँ, स्प्रिंग में सीरीज में कैसे चेक करोगे? एक स्प्रिंग का एक एंड आइदर ब्लॉक के साथ कनेक्ट होगा और वॉल के साथ कनेक्ट रहेगा. दूसरा जो एंड होगा वो दूसरा स्प्रिंग के एक एंड के साथ कनेक्ट होगा. यहाँ पे है?
नहीं है सर.
no, sir.
So they are not connected in series. They are connected in parallel. Parallel में कैसे चेक करोगे? एक स्प्रिंग का एक एंड वॉल के साथ कनेक्ट रहेगा, दूसरा एंड ब्लॉक के साथ कनेक्ट रहेगा. तो ये पैरेलल का कंडीशन है. जैसे ये आपका पैरेलल में है. दूसरा अगर एग्जांपल लो, सपोज मान लो so let us take this spring constant is K1, this is K2, and this is your block. Okay. तो कोई भी स्प्रिंग पैरेलल में कनेक्ट है मतलब क्या है? उसका एक स्प्रिंग एक एंड क्या होगा? वॉल के साथ कनेक्ट है, दूसरा आपका ब्लॉक के साथ कनेक्ट रहेगा. देखो इसमें भी, इसमें राइट.
Yes, sir.
They are actually connected in parallel, not in series. Look like they are connected in series, but this is not true. Okay. How will equivalent spring constant? So again, I'll displace this block by an amount of x. Okay. So if you displace this block by an amount of x, क्या इसमें जो फोर्स लगेगा सेम लगेगा?
F/2 F/2.
No, that will not define whether it is f/2 and f/2. It's not like
Okay,
this,
okay.
because it depends upon, because why I'm saying f/2 इक्वल नहीं होगा. क्यों? क्योंकि देखो अगर x अमाउंट स्ट्रेच किए हो अपने और डिस्प्लेस किए हो मास को, इसका डिस्प्लेसमेंट कितना होगा?
X1.
x नहीं, x सेम होगा.
Okay, okay.
If you displace this block by an amount of x, the stretching of this spring will be x, and same is true for this spring also.
Yes, sir.
Right? Their spring constant is different, so obviously that
Yes.
that force will be different. So that force, let us assume F1
Or
and
F2.
okay. So resultant force is how much? F, that is, मतलब दोनों तो खींच रहा है ना, स्प्रिंग 2 भी खींच रहा है इधर, स्प्रिंग 1 भी इधर खींच रहा है, तो रिजल्टेंट फोर्स कितना एक्सपीरियंस करेगा? F1 plus F2. Exactly. So it will be F1 plus F2. Right? And F is your resultant. So what I can write in place of resultant, if you draw another system that is equivalent, that contains on spring, but that spring is equivalent to the spring of these two springs. Okay. तो उसका जो अगर आपने ड्रॉ करोगे तो उसके लिए जो रिजल्टेंट फोर्स होगा वो इतना ही होगा, F, and F equals to F1 plus F2. So what I am trying to say, in place of F you can write KE into X. Okay, because this is the resultant force. So resultant force you can write equivalent spring constant into displacement, and in place of F1 you can clearly write, because this X is same here, stretching of this will be again X, stretching of spring 2 will be same. So in place of F1 you can write K1 X, in place of F2 you can write K2 X. So K equivalent will be K1 plus K2.
K2.
Same is true for here also. They are connected in parallel, so that equivalent spring constant will be K1 plus K2. Okay,
Okay, sir.
क्या इतना समझ में आया सबको?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now suppose your system is like this. Shall I erase this part?
Yes, sir.
Yes. Yes, sir.
Okay. Now suppose you have this spring, a spring constant of this spring is twice K, and you have two springs here. Okay, you can make proper diagrams. What I'm saying, this side you have spring, that is spring constant is twice K, and here in this side you have two springs, the spring constant is K and K. So what will be the equivalent spring constant for this system? What will be the equivalent spring constant? So see, these two are
Okay.
connected in parallel, right? Check. These two are connected in parallel.
Yes,
No?
sir.
Because on end is connected with block, another is connected with wall. For both cases, obviously they are connected in parallel and their spring constants are same. So their equivalent spring constant will be how much? Twice K. So twice, you can imagine a spring having spring constant twice K, that will be the equivalent spring.
बनवाई क्या रहा सर?
नहीं देखो, ये आपका twice K हो गया, नहीं ये समझ में आया ना? तो स्प्रिंग का स्प्रिंग कांस्टेंट कितना आया? twice K, right?
Yes, sir.
Now this spring again is in parallel with this spring. You see, on end is connected with block, other is connected in wall. On end is connected with block, other is in wall. So they are actually connected in parallel, right? Because it is satisfying
Yes, sir.
that rule. So that equivalent spring constant will be how much now?
K.
Twice K
आ
plus
रहा सर.
twice K,
4K.
right? 4K. So what will be the time period T? कितना हो जाएगा? 2 pi square root of m by m is the mass of that block, equivalent spring constant, right? That formula I have we have discussed that formula. According to that formula, K will be Ke, right? Equivalent spring constant. So that is nothing but you got that is 4K.
4K.
Okay, this part clear what I'm saying?
Yes, sir.
Yes, sir.
Okay. अब तक जो डिस्कस हुआ सबको समझ में आया?
Yes, sir.
Okay. Now we'll go to simple pendulum. Shall I erase this part?
Yes, sir.
Okay. So you remember that formula, right? Time period of oscillation is 2 pi square root of m by k. Now suppose your simple pendulum. So simple pendulum is nothing but you have a rod and on there's a bob having mass m. The length of this rod, let us assume L, and this is the point of suspension, that is let us assume O. Okay. Now if you displace this block, this bob by giving small amount of force, right? So what will be the condition now? So this discussion is simple pendulum. Okay. So आपने क्या है, आपका ये simple pendulum है, एक rod है having length L, there is a bob, mass is M. Now if you displace this bob, this is the equilibrium condition. If you displace by an amount of theta, so what will be the case? And that theta should be so small because for oscillation or simple harmonic motion, that F is proportional to X, right? I mean, there is a linear relationship. So that theta should be so small. This is your length. Now the current position of this bob is here. Okay. So there are two components. This side you will have mg, right? This side you will have mg, and this angle is actually how much? This will be theta. So this side you will have mg cos theta, and that is balancing with tension, right? T. Okay. And you will have mg sin theta this side. So you have displaced this your pendulum along this side. So this displacement is x. Let us assume this displacement is x. So force, that restoring force is acting, that restoring force is how much basically for this displacement? Restoring force will be mg, how much? Sin theta, right?
Yes, sir.
Is it clear what I'm saying? So this is your simple pendulum, its length is L, mass is m. So this is the equilibrium condition. Now you displace this mass by small angle, that is theta. Why it is small angle? Because for simple harmonic motion, that f should be there is a linear relationship between f and x. Okay. So now that pendulum is here, so it will have two components, because mg the mg is acting this side. So along this side you will get mg cos theta, and that is balancing with tension. And this side you will have mg sin theta. So mg sin theta actually will bring this system back. So mg sin theta actually the restoring force, and because of this, that your pendulum will come this side. Now what will be the theta? Sorry, sin theta. What will be the sin theta here? So this is your theta.
Theta.
So this length is how much? X. This length is x. Okay. And this is your hypotenuse. So you can write in place of sin theta, what I can write? X by L, right? I can write because this is your perpendicular. Okay. And this is your hypotenuse, right? So perpendicular sin theta is nothing but perpendicular divided by this length, right? So x by L. Is it clear what I'm saying? And F is actually acting opposite to the displacement, because this side you have taken the displacement and force is actually acting in this side. So you have to take on minus sign. Is this clear what I'm saying?
Sir.
Yes, sir.
इसको समझ में नहीं आया? Is it clear what I'm saying?
Sir.
No?
Yes.
Okay. So you got this mg. So now what will be the k for this equation? So f is nothing but minus mg divided by L into x, right? So see, f equals to k into x, right? So this is actually k. This is actually k, right? So for the time period of oscillation, you know that formula, t equals to 2 pi square root of m by k, right? So m you have, and k is nothing but mg by L. So this m will be cancelled. It will be 2 pi square root L by g.
सर
Yes.
जो फोर्स और mg sin थीटा बैलेंस कर रहे हैं ना, तो वह माइनस कैसे?
फोर्स mg sin थीटा बैलेंस नहीं कर रहा है. जो फोर्स एक्चुअली ये तो आपका पोजीशन, यहाँ आपका पेंडुलम इधर था एट दिस प्लेस. यू डिस्प्लेस बाय ए स्मॉल अमाउंट ऑफ फोर्स. आपने उसको x अमाउंट डिस्प्लेस किए हो. अब इस पोजीशन में आपका फोर्स जो वेट है किधर काम कर रहा है? इधर. This side you will have mg cos theta, right? And
Yes,
that is
sir.
balancing tension. This side you will have mg sin theta. What I'm trying to say, this side you will have mg sin theta. So mg sin theta actually your restoring force that will bring your system along this side like a simple harmonic motion. So mg sin theta के कारण क्या हो रहा है आपका सिस्टम? जहां पे इक्विलिब्रियम पोजीशन है उधर आपका मोशन हो रहा है ड्यू टू mg sin theta. Now what I have taken this minus sign because you have considered your displacement along this direction, right? And force is always, that restoring force will always act opposite of displacement. So this side you have x, so obviously you have to take minus sign because F is opposite to that of displacement. Is this concept clear now?
Yes, sir.
So this is your 2 pi root over Lg. Now I'll discuss on important interesting problem. So इतना लिख लिया आप लोगों ने?
Sir.
Yes, sir.
ठीक है. So now we'll discuss problem. Suppose this is your simple pendulum, its length is L, same system. And initially it is at equilibrium and that point is basically, so I'm not discussing, this is your simple pendulum, length is L, mass is M. Initially at equilibrium position, that point they have given, that is B point, that equilibrium point. Now, if you displace this pendulum by an amount of theta, the position is here, okay, and this point is given as P. Now what will happen? This actually what is happening? Your system is here. You displace by an amount of theta. Now question is, what will be the velocity of this pendulum when it will come back to this equilibrium position? Is this question clear to all? What I'm saying?
Yes, sir.
What will be the velocity? This is your theta L, and this is the position, mass M, point is P. How will
Energy
calculate?
conservation.
Exactly. So you have to consider apply that energy conservation. So let us take that reference point here. I mean, this is the reference point, or I am assuming this is the ground. Okay. Because you have to, why I am considering this reference point, because the potential energy you use to measure from reference point, right? Now this length is how much? This length is how much?
L cos theta.
This length is L, right? Because this is the length of pendulum, right?
Okay, yes, sir.
Yes, sir.
Okay. Now, when that pendulum is here, right? Let us take that corresponding horizontal point is this. Okay. Now, what will be this height or length?
Sir, the height of the P point.
No. Yes. What will be the height of this P point? So this is our
L minus L cos.
exactly. So this is your ground. This length is L. When that pendulum at this point P, what will be the height of this pendulum or this bob? What will be the height? This is this will the height will be this much, right? Height will be this much because this is, you have considered this is your ground or reference point. So just I have taken a line. So this will be the height. So how will calculate this height? Because you know this length is how much? This is small l. This thing you can calculate if you know theta. So this will be how much? This will be how much?
Sir, L cos theta.
Exactly. This is your hypotenuse, this is your base, and angle is how much? Theta. So this length will be how much? Basically, this length will be L cos theta. But you have to calculate this length, right? Because this is your height. This length is L. This is L cos theta. So this will be how much? L minus L cos theta.
L cos theta.
Right? So your height you got, H is how much at point P? This height is nothing but L into 1 minus cos theta. So potential energy will be how much? V at point P, that will be mg H, right? And H is how much? L into 1 minus cos theta. Okay. Now pendulum will come back to this point, right? And this point is V. So at this position, the total energy of that pendulum is how much?
Sir, mg L 1 minus cos theta.
There will be no kinetic energy because this is your extreme point, right? So total energy equals to potential energy, and potential energy you have calculated, that is mgl 1 minus cos theta. Okay. So this is your total energy. So you can write that total energy equals at point P, that will be your potential energy, that is mgl 1 minus cos theta. Now this pendulum will come back here. This is your equilibrium position. So what will be the energy here?
Half mv square.
Half mv square, because this point or this horizontal I have considered this is your ground. So when it will come back here, there will be no potential energy, right? Because height will be 0. So potential energy will be 0. So total energy will be exactly equals to half mv square, or kinetic energy. So energy at point B will be half mv square, right? Now if we apply that energy conservation, so we can write energy at point P should be equals to energy at point B. Energy at point P was how much? Mg L 1 minus cos theta equals to energy at point B, that is half m v square. Okay, m will be cancelled, v will get root over twice gl 1 minus cos theta. Did you get? Is this concept clear to all?
Yes, sir.
सबको समझ में आया? किसको समझ में नहीं आया?
Yes, sir, आ गया.
ओके, सबको? What is the time now?
Yes, sir. Time.
1 minute, let me check. Okay, so this is your pendulum system. Now suppose you kept your pendulum in a lift, inside lift. Okay, so this is your pendulum, its length is L, mass is m. Okay, and that lift is moving upwards with acceleration a. So what will be the time period of your pendulum now? So this is your pendulum. You attach this pendulum inside a lift, and that lift is moving upwards with acceleration a. So what will be the time period of this pendulum? What will be the time period?
T is equal to 2 pi root L by G.
Yes. So when you see, when that that lift will move upwards with acceleration a, the pendulum will experience a pseudo force, and that will act downward, and that force will be how much? Ma. Okay, this pendulum already have weight, that is mg, and mg and ma, they are in same direction. So basically the effective g will becomes g effective, that will be g plus a, right? So when that your lift is moving upwards, this pendulum will experience a pseudo force downwards, and that force will be m into acceleration, and your weight of the weight is also acting in the same direction, that is mg. So the effective g will becomes g plus a. So now you know that how to calculate time period. 2 pi square root of L g plus, or the formula is g effective, so it will be g plus a. Is this part clear? Is this
Yes,
part
sir.
clear? Okay, now if it is moving downwards with acceleration a, then what will be the formula? Now the same thing, बस आपका जो सिस्टम है Now your lift is moving downwards with the acceleration A. What will be the time period now? Time period of this pendulum?
G minus.
Exactly. Now your pendulum will experience pseudo force that will act upward, and that amount is MA, and weight is always act downward, that is mg. So effective G will become, for this case, it will be, since they are in opposite direction, so it will be G minus A. So time period T will be 2 pi square root of L G minus A. Okay.
Yes, sir.
Okay. Is this part clear to all?
Yes, sir.
Okay. सबको समझ में आया?
Yes, sir.
Okay.
Yes, sir.
Now I'll
Sir.
modify. Suppose same system, you have lift, and inside lift you have simple pendulum, mass is m, length is l, and let us take, this is your positive y axis. Your lift is moving along positive y axis with given equation. They have provided you that equation of this, equation of motion of your lift. So what I'm saying, your lift, inside your lift you have again same system, pendulum, so length is l, mass is m. Now lift is moving in positive y axis, and equation of motion is given, or solution of equation of motion is given, y equals to kt. Okay, y equals to kt, where k equals to 1 meter per second. Now what will be the time period of oscillation of your simple pendulum? Is this question clear to all? What I'm saying? So
Yes, sir.
you have lift, inside lift you have simple pendulum, and lift is moving upwards, and that upwards direction is taken as y axis, and equation of motion of this lift is given y equals to kt. So this is the equation. So now if that lift is moving with this equation, so what will be the time period of oscillation of your pendulum? Y equals to kt, that is given, k is 1 meter per second. Now anyone can calculate this? Is this question clear to all?
Yes, sir.
Yes, sir.
Everybody?
Yes, sir.
Yes, sir.
Okay. So I will calculate again. So you know this y, right? Y equals to kt. So if you I have to calculate acceleration, right? Because anyway you have to calculate the time period. You have to calculate effective G, right? That you have to calculate. So for that you have to calculate the acceleration of your lift. So this is, they have given that equation of motion is given. So if you differentiate with respect to time, so first it will provide you speed, right? So it will be dy by dt, and that will be basically k. To get acceleration, you have to differentiate further. So it will be a equals to del square y by del t square, and that will be 0. So there is no acceleration, right? So time period will be how much? 2 pi. So if there is no acceleration, so G effective will be how much? Simply G. So it will be 2 pi Ly. Is it clear?
Yes, sir.
Yes, sir.
Okay. Now if they provide, now I'm giving homework. Now equation of motion is given like this. Y equals to kt square, and k is given 1 meter per second square. Now you have to calculate time period. This is your homework. Please do it. Okay. Please do it.
Yes, sir.
Okay. नाउ सपोज आपका एक पेंडुलम है, सेम सिस्टम, एक गाड़ी के अंदर रखा है, ठीक है। सपोज मान लो ये आपका कोई गाड़ी है, इसके अंदर रखा है, और दैट योर व्हीकल इज मूविंग विथ एक्सीलरेशन ए, विथ एक्सीलरेशन ए आपका गाड़ी फॉरवर्ड डायरेक्शन में जा रहा है। ओके, नाउ व्हाट विल बी द टाइम पीरियड ऑफ ऑसिलेशन ऑफ योर पेंडुलम? So when it is moving, your vehicle is moving forward direction, it will experience a pseudo force along this direction, opposite direction, right? And that will be ma. So you have two, this side you have mg, and perpendicular to this you have ma, right? So what will be the g effective now?
G square plus A square the root.
Exactly. Is this part clear to all? So इस साइड आपका क्या है, mg काम कर रहा है, और this side it will that pseudo force, that is ma. Now what will be that g effective? So this angle is how much? 90 degree, right? So how will calculate that effective g? G effective will be root of r. So you can treat like two vectors. How you will calculate that resultant of these two vectors? So it will be g square plus a square plus 2g a cos 90. So this term will be 0. So whatever Punit is saying, it is correct. This is g root over g square plus a square. So for this system, your time period will become t equals to 2 pi square root L by square root g square plus a square. Okay. Is this part clear? What I'm saying?
Yes, sir.
Everyone?
Yes, sir.
Shall I erase?
Yes, sir.
Now we'll discuss another important topic, that is the oscillation of floating body. The topic that I am going to discuss, that is oscillation of floating bodies. This is a very interesting and important topic. Okay. So suppose you have a cylinder. Okay. Its area of cross section is capital A. Its length is small l. Okay. And density of this cylinder is rho. Density of cylinder is rho. So I can write its mass, right? So m will be how much? So mass of a body is nothing but rho
Rho
into,
AL.
so
Rho
rho,
AL.
rho into volume, right? So it will be rho AL. Very good to all. Now what I'm saying, suppose this cylinder is emerged in some liquid. इसका जो कुछ part है, so what I'm saying, suppose some of its parts is inside some liquid, and let us consider the density of this liquid is rho naught. The height, जो सिलेंडर का हाइट जो आपका लिक्विड के अंदर है, वो मैंने h अज्यूम किया, So sum of the part of that cylinder is actually inside some liquid, and its density is rho naught. Okay, and this is the actually equilibrium position. So equilibrium position means there is no force acting on this cylinder. So what I'm trying to say, your cylinder, h length of this cylinder inside the liquid, the density of this liquid is rho naught. Okay, so this is the scenario of equilibrium condition. Equilibrium condition means there is no force acting on this cylinder. So why that no force is acting on that cylinder? Because there are two forces that is acting exactly opposite to each other, opposite direction में काम कर रहा है. एक तो एक आपका सिलेंडर है, तो एक डाउनवर्ड फोर्स काम करेगा. कौन सा फोर्स काम करेगा डाउनवर्ड?
Gravity force.
Exactly, mg. And on force will act opposite to this or upward. That will be which force?
One force.
Upthrust force, right?
Yes, sir.
And let us denote this upthrust force is U. So how much it will be? So upthrust force is nothing but volume displaced by this body. How much it will be? Volume displacement. So कैसे कैलकुलेट करोगे वॉल्यूम डिस्प्लेसमेंट? जस्ट जितना वॉल्यूम इस सॉलिड का लिक्विड के अंदर है उतना इसने डिस्प्लेस किया है. कितना होगा फिर? दिस हाइट इनटू एरिया, राइट? So
Yes, sir.
upthrust force is nothing but volume displaced by the body into density of liquid into g. That is your upthrust force. How will calculate that volume displaced by the body? That is nothing but volume inside that liquid. Volume inside that liquid, how will calculate? Just इसका height, इसका cross section. So upthrust force will become volume. Volume is how much? Simply A into H, that is your volume. Then rho naught, that is the density of your liquid. Then G. Is this part clear? So in equilibrium condition, when this system is at equilibrium at this situation, so this means the mg should be equals to upthrust force, and that is nothing but ah rho naught g, right? Now if you displace this body by small amount, and that is x, आप इसको क्या किया आपने? फर्दर एक थोड़ा फोर्स लगा के x अमाउंट फिर नीचे किया लिक्विड के अंदर. तो पहले कितना लिक्विड के अंदर था? h था. आप उसको थोड़ा सा, जैसे कोई बॉडी का ऑसिलेशन चेक करते हैं, कैसे चेक करते हैं? जस्ट उसको इक्विलिब्रियम पोजीशन से उसको ऑसिलेट करने के लिए फोर्स देना पड़ता है. तो अभी तो इक्विलिब्रियम पोजीशन में है, इसको ऑसिलेट कराने के लिए आपको थोड़ा डाउनवर्ड फोर्स देना पड़ेगा. सो नाउ लेट अस अज्यूम सम फोर्स यू हैव गिवन. अब इस सिचुएशन में क्या हो जाएगा? आपका जो वॉल्यूम, द लेंथ दैट इज इनसाइड दैट लिक्विड, दैट बिकम्स h प्लस x. तो आपने थोड़ा फोर्स लगा के उसका जो लेंथ है इनसाइड दैट लिक्विड, दैट यू आपने कितना किए हो? उसको h प्लस x किए हो. इस केस में उसका अपथ्रस्ट फोर्स कितना हो जाएगा?
सर h प्लस x हो जाएगा उसमें.
Everybody got what I am trying to say? What I am trying to say समझ में आया? नहीं आया होगा.
No, sir.
ओके, तो प्लीज टेल मी, जहाँ पे आपको समझ में नहीं आया वो आप बोल दो वहीं पे ना. मेरे को समझ में नहीं आता ना, आप लोगों को समझ में नहीं आ रहा है कि नहीं. इनिशियली इक्विलिब्रियम कंडीशन में क्या है आपका? कितना लेंथ इनसाइड दैट लिक्विड था आपका? h अमाउंट, राइट?
H. Yes, sir.
Okay, that time upthrust force is how much? Volume displaced by this solid, that is A into H, density of liquid, that is rho naught, into G, that is upthrust force, and that is actually acting upwards. And downwards में क्या कम कर रहे हैं? उसका weight कम कर रहे हैं बॉडी का, सॉलिड का, ना, mg. So in equilibrium condition, mg should be equals to upthrust force. Now to investigate that oscillation, what you have to do, आपको उसको जो बॉडी है उसको थोड़ा सा और नीचे, सपोज मान लो एच अमाउंट ऑफ एच लेंथ उसका लिक्विड का अंदर था ना, अब इसको थोड़ा नीचे की तरफ फोर्स देके इसको h प्लस एक्स क्यू हो, मतलब क्या है, h प्लस एक्स अमाउंट ऑफ लेंथ is actually inside the liquid. Did you get what I'm trying to say?
Yes, sir.
Initially its length inside that liquid it was h. Now आपने थोड़ा डाउनवर्ड फोर्स लगा के इसको कितना किए हो, h plus x किए हो. Now in this situation upthrust force will no longer be same as mg, because mg तो हमेशा mg रहेगा, but upthrust force क्या हो गया, अब चेंज हो गया, क्योंकि आपका volume displaced by that liquid that is changed now, because length is become how much, h plus x, right? So in this situation upthrust force will be how much, anyone? Didn't get, I think,
A
right?
H plus X rho naught into G.
हाँ, पिक्चर ड्रॉ करने दो फिर क्लियर हो जाएगा. So initially कितना था आपका volume inside that your liquid, that is h, right, that length. Now it displace, आपने थोड़ा डाउनवर्ड उसको फोर्स दिया, now this length become h plus x, this length. Okay, so if this length is h plus x, then upthrust force will become how much, area, right, a into h plus x into rho naught g. Is it clear now?
Yes, sir.
Yes, sir.
Okay, now net force is how much? In this scenario, net force will not be equals to 0, because upthrust force will be higher as compared to mg. So net force will be mg minus a into h plus x rho naught g. Okay, and mg is actually how much, according to that equilibrium condition, what we got, mg equals to how much,
A H rho naught G.
a h rho naught g, right? So if you substitute it here, a h rho naught g, a h plus x rho naught g. So this will be cancelled on term, you will get only minus a x rho naught g, right? And that is your f. So यहाँ पे देखो k is how much actually, k आपका basically देखो a equals to minus kx, so what you can write from here, a rho naught g x. So this is your actually k, f equals to minus kx. तो अगर इस बॉडी को थोड़ा अपने नीचे की तरफ अगर इसको और थोड़ा ये कर दिया, अंदर कर दिया लिक्विड की तरफ, नाउ इट विल, व्हाट विल इट विल डू, इट विल ऑसिलेट. दैट्स व्हाई दिस टॉपिक oscillation of floating body. So when it is at equilibrium, if you displace further, now it will oscillate, right? And you got that equation, that f equals to minus kx, k is how much, a rho naught g. Is it clear?
Yes, sir.
Yes, sir.
Okay, now what will be the time period?
2 pi root m by A rho naught G.
2 pi root over m. M is how much? M is the body mass of that solid body, and that mass is how much, basically al rho, right? And you have this a rho naught g. So it will become 2 pi square root of L rho divided by rho naught g. This mass you have calculated, right? This is the mass of your cylinder. So mass means volume. Volume means area into length, right? Into rho. That is mass divided by k. K is how much? K is this. Is it clear now?
Yes, sir.
क्या
Yes, sir.
सबको समझ में आई है?
Yes, sir.
Okay. Now we can take 5 minutes break, then we'll start. Okay. We'll take 5 minutes break, okay?
Yes, sir.